Hello, today is day 3 of our weather instrument design project. And so what we're going to do today is we are going to write a procedure for testing the instrument that you will create on our next day together. So what you have to do is you have to write a step-by-step procedure on how you're going to test your design, and then you're going to use this to carry out your investigation. So on the document right here, I have started numbering step 1 and step 2, but there will be many more. So you just need to make sure that you just keep adding the numbers on there. All right, so let's look at a couple things here. In Canvas, I have 2 links posted. One is for Rainbow Lab. We did this at the beginning of the year. It's an example of procedure, how to write a procedure, step-by-step directions. Take a moment and look at this. You also have a data table at the bottom. So you need a data table for the experiment that you're going to do also. The second example I have for you is measuring speed. This is something we will do in the spring when we do our force and motion unit. This comes from one of our CPUP books, the science books that we use. It's got the materials listed right here. It's got step-by-step instructions on how that you're going to carry the experiment out. There's a data table and everything. So these are examples for you to look at. So what you're going to do is you're going to go here, and you and your partner are going to go step by step what you need to do. You also need to create a data table. You and your partner can have the same things for these 2 sections right here. All right, so you're going to write a step-by-step procedure. The second part is outline how to manipulate the variables and outline how the data will be collected. So remember, at the beginning of the year, we talked about independent variables and dependent variables. And so as a reminder, let me go here, an independent variable is the factor that you changed during the experiment. You're only changing one factor at a time so that everything else remains the same. So if you are doing an anemometer where you're measuring wind speed, your independent variable is going to be the wind speed. The independent variable will be the wind speed. If you are doing a wind vane, then your independent variable is the direction from which the wind is blowing. The direction from which the wind is blowing. The dependent variable is the factors that's measured during your experiment. The outcome depends or responds to the change in the independent variable. So if you are doing the anemometer, your dependent variable is the rotations per minute. The rotations per minute. If you are doing a wind vane, your dependent variable is the way that the wind vane is pointing, the direction the wind vane is pointing. Okay, so you have to name both of those. And then how will you collect the data from this investigation? Create a data table that you will use. So if you go back and look at the second one, hold on, I'm trying to find it here. Here's a data table right here. See, they've got trial 3s. They did the experiment 3 times. On this one, the distance stayed the same. And then our independent variable is the time, and then the speed is the dependent variable. So you need to create a data table like this where you have at least 3 trials. And to do that, here, you can go up to Insert, and you can go to Table right here, and you could, however many sections you want on it, and you just click that, and it will create a table. Then you're going to go down to criterion B3, outline a testable prediction using scientific reasoning. And we're going to use the if-then statement. So you're going to type in there, if blank, then blank. So you're going to tell me, if I do this, then this will happen. All right, so that you're going to make a prediction. And then the rest of this we'll build the instrument on Monday when we come back, and then we'll do the rest of this after that. If you have any questions, ask me in class, and I will look forward to seeing what you guys are doing.